In this lesson, we are going to learn how to define a polynomial function and how to classify them. So a polynomial function is a function where the exponents are whole numbers. So that means 0, 1, 2, 3, etc. So no fractions or decimals. And the coefficients are real numbers. So things that would not be allowed would be things like the square root of -2, because that would be imaginary, so no imaginary values. But fractions are fine, negatives are fine, decimals are great, square roots, irrational numbers, that's fine as long as it's real. In the following table, identify each of the following as a polynomial function or not. So as I look at g of x, -5 and -8, the coefficients are both real, and the exponent's a whole number, so this one is great. My next one might be a little bit confusing, but if you remember what a negative exponent does, it causes it to move to the denominator. So this would be equivalent to -2 times x to the -1st, so this is no. You can't have a variable in the denominator because that's equivalent to a negative exponent. As I look at the next one, my exponents look good. They're both whole numbers, 8, 3, and the square root of -2. This one sometimes throws kids off, but this is irrational, so this is fine. It is a real number. It's just when it's non-real that it's okay. Next one's good as well. It's just a constant term. This would be the same as -8x to the 0 power. H of x, this one, we have an issue. The fractional exponent is not okay. In number 6, there is an issue. There is a negative number as an exponent. The exponents need to be whole numbers, and negative values are not. Take a look at number 7, our last one, -2 to the x power. Well, x could be anything, and since it's an exponent, it could be a decimal fraction. It's variable. It's a variable. So this is not a polynomial function because the variables can't be exponents. Some more vocabulary coming at you. So, standard form. We've looked at standard form with quadratics. Well, this is where the terms are written in descending order of the degree, meaning the exponent. We'll talk a little bit more about this in a second. So let's illustrate it with this f of x. Is it in order from least to greatest by the exponents? No, I see a 4x to the 5th as the greatest one, so I'm going to rewrite this as f of x is equal to, and I'm going to put the one term with the highest exponent first. So 4x to the 5th. Next I would have minus 2x cubed. Then plus 3x squared would be my quadratic term, and lastly, minus 5. So let's talk about the degree. I've always said the degree, think of how hot is it? It's in the degree spot, like a degree symbol. It is your highest exponent on x. So in this case, we have a 5th degree polynomial. Now, if we're looking at just a polynomial, we'll see some special cases where we need to do something else to determine the degree. For instance, if you have a polynomial where you have like x squared y cubed plus 2xy, the degree on this one is actually, this is just a polynomial, not a function, the degree here is 4. Why is that? Because this term right here, which is held together by multiplication, has a degree of 1 and a degree of 3, and you find their sum to state that the overall degree is 4. Notice I did not need to sum anything here. I'm not adding these different terms together. It's just the one that's highest, and the exponent is only a 5 here. Okay, next, the leading coefficient. Once it's in standard form, it is your coefficient on that first term. So our coefficient is 4. How many terms does this polynomial function have? Well, terms are separated by a plus or minus sign. So this particular one has 4 terms. They are what you see here, the 4x to the 5th, -2x cubed, 3x squared, and minus 5. And what's my constant term? It is the one that has a coefficient on x sub 0. Well, that's going to be my -5. Okay, just think of it as your plain old number. Polynomials are named by both their degree and the number of terms they have. So over here in the left, here are the names we give to polynomials based on their degree. Constant, linear, quadratic. We've dealt with all of these so far in Algebra 2. Third degree cubic, fourth degree quartic, fifth degree quintic. If it's 6 or higher, we just say 6th degree, 7th degree, 8th degree. You could probably find a huge list somewhere on the internet, but common practices is to stop at 5, which is quintic. Based on the number of terms, if it has 1 term, we call it a monomial, 2 terms binomial, 3 terms trinomial. If it's 4 or higher, we just typically say it's a polynomial. All right, so let's start with number 1 here, and we're going to classify it by its degree. So the degree here is 2. It's the highest one. So since it's 2, this would be quadratic. And I see 3 terms, so this would be a trinomial. So we could say it's a quadratic trinomial. Number 2, highest degree is 1, so this is linear, and I only see 2 terms, so it's a binomial. Number 3, I see a tricky one. So what's the degree here? The first term is a degree of 3, but the second one, this is a special case where I've got to add it together. This has a degree of 4, so this is actually quartic, and it has 2 terms, so it's a quartic binomial. Number 4, again, a tricky one. This would have degree 3, so it's cubic. Why? Because we actually have to add that 2 and the 1 together. I see just 2 terms, so it's binomial. Remember, terms are separated by plus and minus signs. Number 5, the degree here is 0. It's not 1 because there's no variable at all. So it is a constant function, and it would be a monomial because there is only 1 term. Lastly, it's important that you can start recognizing the graphs of polynomial functions. So let's talk about some of the different degrees. Linear, well, you better know by now that that's a line, and perhaps it has a positive slope or a negative slope. Quadratics, you should know they make parabolas when we graph them. So I encourage you to play around with your graphing calculator. Check out what something to the 3rd power looks like. What does something maybe to the 4th power look like? And it could be plus 4. You could make it all kinds of, make it complicated. So pause the video, check out a few graphs. So hopefully one of the things you're seeing is that all of these are curves that can be created by not picking up my pen or my pencil. So a cubic looks something like this. A quartic function can look something like this. And you're going to learn how to recognize different characteristics of these graphs as we go throughout this unit. And it's not all that complicated. I know you think, how do I remember what does a 5th and a 6th and a 7th? Well, they start to fit these overall patterns that you'll know what the overall graph looks like just based on the degree and the leading coefficient.